Okay, welcome to your video lesson for June 1st. It is on present value of annuities, so building off of the previous lesson for future value. This is your last major lesson for this unit. We're going to continue to recognize what an annuity is, and then we are going to use the present value annuity formula to solve 3 different word problems. The present value of an annuity, this side of annuities, is used in situations like a mortgage or long-term investment. For a mortgage, you are given a lump sum of money, you need to repay in regular payments. Or you could have inherited a lump sum of money and you would like to make regular withdrawals from it. The formula. So we're looking for the present value or principal. So P equals PMT, your payment, 1 minus 1 plus R over C to the negative CT, all divided by R over C. So all of those variables are the same as what we've seen so far for compound interest, and then yesterday, finding the future value of an annuity. This right here, the P value is the present value, or you can think of it as the principal value. Our first example, Nick's grandparents invest some money in an account such that he can get $500 a month from it for the 4 years he's in university. If the account pays 4% compounded monthly, how much would they have to put in the account the day he starts? So how you distinguish this from yesterday's stuff, similar to the normal compound interest versus present value compound interest, we're still looking for keywords or key statements like $500 a month, compounded monthly. That's how it tells us it's compound annuity. But instead of it asking how much is it going to be worth at the end, it's asking stuff like the day he starts, or today, or now. So we don't have an A value anymore. We have our variables P, PMT, R over C, and CT. So it's asking how much does he want the day he starts, how much do they have to put in the day he starts. That's your question mark. They want it so that Nick can withdraw $500 a month. So there's his payments. Our interest rate, 0.04 over 12. That does not work out to be a nice decimal, so we're going to leave it like that. And our CT value, 12 times, and it says the 4 years he's in university, so 12 times 4 is 48. Using our formula, present value equals $500 a month, 1 minus 1 plus 0.04 over 12 to the negative 48, all divided by 0.04 over 12. Once you type that all into your calculator, you should get 22,144.42. Just like yesterday and all along, there are some ways that you can tell if that number seems legit or not. Figure out how much money Nick actually withdraws. So if he withdraws $500 a month times 48 withdrawals, 4 years, 12 once per month, that works out to be $24,000. So his grandparents put in 22 grand and change. He was able to, through that annuity, through that investment, that made up the extra roughly $2,800 that he would have withdrawn. So if that number, present value, ends up being more, then that means that you probably made a mistake, because we're not dealing with investments that have losses associated with them. Example 2. You inherited 50 grand but don't want to waste the money, so you invested at 5.4% compounded monthly in an account that will automatically give you monthly payments for 2 years. How much will you get every month? Keywords. Compounded monthly. You inherited 50 grand. It's going to give you monthly payments. How much will you get every month? So it gave you the present value, how much you inherited. It wants to know how much the monthly payments would be if you're going to make equal withdrawals for 2 years. Your interest rate, 0.054, your compounding period monthly, 12. See if that works out to be a nice decimal. It indeed does, so we should get 0.0045. And our CT value, monthly, 12. You only want to make the withdrawals for an even 2 years, so times 2 equals 24. So going into our formula, 50,000 equals PMT, 1 minus 1 plus 0.0045. 2 negative, what do we get, 24? Divided by 0.0045. Just like yesterday, when you're looking for the payment, you can figure out what everything inside that square bracket is. Don't clear that number from your calculator, and then divide 50,000 by that number to figure out what your payments are. So let's take a second now, figure out how to use your calculator, figure if you get the same answer as me. I get a payment of $2,202.54. Hopefully that's what you got. So that's how much that you can withdraw every month for 2 years. Again, if you want to see if that makes sense, take that number, multiply that by how many withdrawals you made, which was 24. When you do that, I get $52,860.90, which that's a good thing. That means that my 50 grand actually made me money, made me roughly $2,800. That's good. That means that I withdrawed more than I put in. My investment was good. It actually made me some money. And then finish it off with a therefore statement. Our last example, you need a loan of $360,000 for a house. If the interest is 3.19%, compounded monthly over a 20-year period, how much are your monthly mortgage payments, and how much interest did you pay in order to buy your home? Excuse me. So again, it's asking us how much are your monthly payments, and it gave you compound interest, it gave you monthly, and it gave you the present value. That's the value of the home that you would like to buy. So your present value, $360,000. Your payment, you're trying to figure that out, how much you're going to pay for your house. The R over C, 0.0319, compounded monthly, so divided by 12. See if that works out to be a nice decimal. Not, so we're going to leave it as a fraction. And then CT, 12 times, and you pay your house off or your mortgage off in 20 years. So that's 240 payments. Using our present value annuity formula, 360,000, PMT, 1 minus, 1 plus, 0.0319 over 12 to the negative 240. All divided by 0.0319 over 12. Just like our last example, to figure out the payment, figure out what everything inside that square bracket is, don't hit clear on your calculator, and then divide $360,000 by that answer. And again, if you don't have the answer button on your calculator, you kind of got to do it BEDMAS style, cross multiply, divide, do it step by step. Take a second, figure it out on your calculator, see if you get the same answer as me. I get a monthly mortgage payment of $2,030.97. Seems like a reasonable mortgage payment, or at least in terms of the numbers in this question, which, by the way, that interest rate is the current mortgage rate at most institutions right now, and $360,000 for a house would get you probably an average to above average house at this point in the market. How much interest did you pay in order to buy your home? So you made that payment, $2,030.97. You made that payment 240 times. So if we multiply that by 240, that will give you how much you actually paid for your home, including the interest. So it ends up, when you multiply that by 240, your house actually cost you.
Can the following students please come to the office?
So your house actually cost you $487,000, $431.68. If you wanted to figure out how much interest did you have to pay in order to buy your home, the cost of lending that money you didn't have, subtract the value of your home when you bought it, and when you subtract $360,000, you get $127,000, 431 cents, and 68 cents.
Room 212, please. Morgan Fernandez and Braden Lane to room 212. Thank you.
So therefore, the cost of actually buying your home cost you an additional $127,000 and change, which again, that's probably why most of you, almost all of you, a mortgage is going to be, a house with a mortgage is going to be the single biggest investment that you ever make. So that ends today's lesson for present value of annuities. Hopefully everyone had a good evening, had a good day, going to have a good weekend. And don't forget, Monday we're going to have a very short, just kind of loose end type lesson. A little bit of review worked in there. Tuesday, full day for review. And then your second last test of the year is going to be on Wednesday, June the 6th.